Here we want to graph these two functions, and we're going to just graph by making a table of values as it's indicating, starting with -2 and ending with 2 using integers. So when we plug a -2 in for x here into the f of x function, which is just 2x, so I do 2 times -2, that gives me -4. Plugging in a -1 there is 2 times -1, so -2. Plugging in a 0, we get 2 times 0, which is 0. Plugging in a 1, 2 times 1, and plugging in a 2, we get 2 times 2. So that gives us those 5 points to plot for graphing that function f. So let's go ahead and get those points plotted before we look at the function g. So I have the point -2, -4, and then we've got the point -1, -2, and then 0, 0, 1, 2, and 2, 4. So those are all nice and lined up in a straight line, so we go ahead and connect those with a line, and that's the graph of f. And now we'll go ahead and fill in the same type of table here for the function g. So g of x is 2x minus 3. So when x is -2, that's 2 times -2, so -4 minus 3, that makes -7. When x is -1, we get -2 minus 3 is -5. When x is 0, we get 0 minus 3, so -3. Then we get 2 minus 3, it's -1, and 4 minus 3 is +1. So let's go ahead and plot those points. It's -2, -7, -1, -5, 0, -3, 1, -1, and 2, 1. And again, we see those are lined up, so we'll go ahead and connect them with a straight line, and that'll be the graph of g. And then we're being asked to comment how the graph of g is related to the graph of f. Well, certainly we can see that the graphs are parallel, but more specifically, to obtain the graph of g from the graph of f, we could have just simply moved all of the points down 3 spaces. Okay, and that's really indicated back in the equation by starting off with that same expression of 2x, and then g of x just has that -3. So that -3 is indicating that we're just going down 3. So any point that I picked on the graph of f, if I moved it down 3, I would land on the graph of g. So the graph of g is the graph of f moved down 3 units.